The Additive Manufacturing Laboratory at the BioPACIFIC MIP is a user facility that stands out by offering access to both industrial and research-grade 3D printers. This means that anyone across the country can tap into our resources, whether by visiting in person or making sample requests remotely. At its core, 3D printing, or additive manufacturing, is a groundbreaking technology that constructs objects layer by layer, adding material in a precise, controlled manner. It's akin to sculpturing with clay, where material is added progressively as opposed to traditional methods that remove material. This entire process springs from a digital 3D model. The model is sliced into individual two-dimensional layers, which are then meticulously stacked and fused together to bring the three-dimensional object to life. The laboratory is equipped with a diverse array of 3D printing technologies, each with unique mechanisms for layer construction and material states, whether liquid or solid. Notably, our facility specializes in two cutting-edge technologies: extrusion deposition and light polymerization. Extrusion deposition is a technique where material is selectively deposited throughout a nozzle, building objects from the ground up, one layer at a time. We use thermoplastics that are heated to a specific transition temperature or for extrusion, as well as hydrogels that maintain their shape post-extrusion. Our light-driven 3D printers, utilizing digital light processing, or DLP, work by projecting each layer of the object to be solidified in succession, enabling faster production speeds than extrusion-based methods. This process benefits from precision light sources that polymerize materials layer by layer. Our lab boasts printers that operate across multiple wavelengths, from violet to far red, enhancing biological compatibility and allowing for the creation of complex multi-material structures. Researchers utilizing our facilities have pioneered the development of innovative materials, such as catalyst-free resins that can undergo room temperature exchange at their cross-linking sites. This advancement paves the way for materials capable of interfacial welding and post-printing modifications, opening new avenues for research and application. Our laboratory is not just a collection of advanced equipment, it's a gateway to accelerating research and innovation in additive manufacturing. By providing access to cutting-edge 3D printing technologies and expertise, we empower researchers and innovators to explore new frontiers in their fields. Throughout our contributions, we play a crucial role in advancing the center's missions to foster technological innovation and collaboration.